Good afternoon, class. We are looking at section 3.1, derivatives and rates of change. Here's chapter 3, derivatives. Section 1, derivatives and rates of change, tangents. We will continue to the derivatives as a function, basic differentiation formulas, the product and quotient rules, the chain rule, derivatives of the logarithmic functions, differentials. So let's quickly recap what we have discussed as far as limits are concerned, limits of functions. Here's a simple definition. Limit of f of x as x approaches a, and we read it as follows. When you're dealing with a sequence, a sub n, the limit of a sub n as n approaches infinity is L. We say that the sequence a sub n converges to n. If it's infinity, negative infinity, or d&e does not exist, it diverges. To find limits, simply plug in the value and observe. If you look at all of these cases, when x approaches a along the x-axis from the left and right, along the curve from the bottom and the top, along the y-axis from the bottom and top, they approach the same spot with the y, the same spot, meaning here with the y coordinate L. Therefore, the limit of f of x as x approaches a equals L for all these three cases. But what about the differences? In this case, as x approaches a, also f of a equals L. So therefore, it's a matter of being continuous at x equals a. Over here, there's a hole here, and f of a is defined as something other than the limit b. So it's discontinuous at that point. And in this case, f of a is not even given to us, it's undefined, it's unknown. Horizontal asymptotes have a specific definition. When the limit of f of x as x approaches negative infinity or positive infinity is L, we say y equals L represents the horizontal asymptote for the function or curve y equals f of x. When the limit of f of x as x approaches a, or a from the left or a from the right, we end up having a negative or positive infinity, then x equals a represents the VA, vertical asymptote. When the one-sided limits are equal, meaning the limit of f of x as x approaches a from the left is L, the limit of f of x as x approaches a from the right is L, then the limit of f of x as x approaches a is also L. Now, derivatives, section 3.1, derivatives and rates of change, tangents. Given y equals f of x and point P having coordinates a and f of a. So here's the function and here's this point. The slope of a secant line PQ, if you pick another point on the curve and you connect them, the line that it creates is called the secant line PQ, if you continue indefinitely on both sides. So the slope of this secant line is called the average rate of change of y with respect to x. Everybody remembers rise over run, delta y over delta x, so y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If we look at this, where we call this a, and therefore this is f of a, and this one is x and f of x, then y sub 2 minus y sub 1 becomes f of x minus f of a. X sub 2 minus x sub 1 becomes x minus a. And again, x minus a is the run, f of x minus f of a is the rise. Rise delta y over run delta x. If we look at this graph, and we still keep this as at a, but this distance now we call it h, therefore this becomes a plus h, and this one is now f of a plus h. Then the formula becomes f of a plus h minus f of a over a plus h minus a. This is a plus h. minus a, which simplifies to h. If we say now this point has coordinates, okay, as a, b and f of b, this is b, everybody. B and f of b, then it gives rise to this equation. F of b minus f of a over b minus a. So what are we trying to say here? All of these equations refer to one thing and one thing only, the average rate of change of y with respect to x, that we know it as this slope. Given 2 points, calculate this slope. Now, this one more specifically, and sometimes this one we refer to it as a difference quotient. Now, if we take a look at this one, you have all these blue lines known as a secant line. And we have this red line as the tangent line because there's 1 point that it crosses the function. The tangent line is the limiting position of the secant line PQ as Q approaches P. So as Q gets closer and closer to P, it gives rise to this line known as a tangent line. And we can write now the slope of a tangent line, also known as instantaneous rate of change, is m of tangent line, which is the limit of m of PQ, this line PQ, as Q approaches P. If we go with this one, limit of f of x minus f of a over x minus a as x approaches a. So as x approaches a. If we go with this one, the limit of f of a plus h minus f of a over h as h approaches 0, as h approaches 0. So the distance h is approaching 0. They all mean the same thing. Therefore, m or f prime of a has this formula that was mentioned, limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0. Reminding you of equation of lines, for example, standard form is ax plus by equals c. Point slope is y minus y1 equals m times x minus x of 1. And the slope intercept form y equals mx plus b. So if we are interested in finding the equation of a tangent line at this point, which has coordinates a and f of a, we're going to put it into this formula. Y minus y sub 1, which is f of a, equals m times x minus x of 1, which is a. And what is m? F prime of a or m. Do I have to memorize this formula? No, point slope is good enough, everybody. It gives you the same thing. And I hope everybody's fine with that. All right, the difference quotient. There are different ways of representing them. Ultimately, it's the average rate of change of y with respect to x. Delta y over delta x, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line PQ. So you have P, you have Q, pick up two pairs. And if you represent the points anyhow that you want to represent, x sub 1, f of x sub 1, x sub 2, f of x sub 2. This is run, delta x or x sub 2 minus x sub 1. This is rise, y sub 2 minus y sub 1, or f of x sub 2 minus f of x sub 1. Now, we recognize the following limit as the derivative of f prime of x sub 1. These are all the same thing that we've seen in the previous page. Limit of delta y over delta x as delta x approaches 0, if you use this one. If you use this one, limit of f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 as x sub 2 approaches x sub 1. If you want to go with this one, limit of f of x minus f of a over x minus a as x approaches a. And if you want to go with this one, limit of f of a plus h minus f of a over h as h approaches 0, they all have absolutely the same meaning, okay? So we could say this is x plus h. We could say this is a, this is x. So there are different ways of writing them, so just in case. So you can say this is x plus h. You can say this is a, this is x, or just the way it's written, x up 2, x up 1. They all have absolutely the same meaning. And so the derivative f prime of a is the instantaneous rate of change of y equals f of x with respect to x when x equals a. And again, reminding you of the same formulas that have been discussed. These are the two main formulas for that. And now it's time to look at this concept. The average rate of change is m of the PQ, the secant line. The instantaneous rate of change is m of the tangent line, the red line, or f prime of a. And so we want to find the average rate of change of f of x, which is x squared minus 3x from x equals 2 to x equals 4. First, I want to show you what we have done before in elementary algebra. Just find this slope given 2 points. That's the concept, average rate, f of b minus f of a over b minus a. So if I want, this is the average rate of change using f of b minus f of a over b minus a. I'm going to go with f of 4 minus f of 2 over 4 minus 2. That's what we are looking for. So in short, plug in number 4 minus plug in number 2. The bottom is clear, b minus a, 4 minus 2 is 2. So if I plug in 4, I get 4 squared minus 3 times 4, minus, if I plug in 2, I get 2 squared minus 3 times 2. We need to simplify this. (16) minus 12 is 4. 4 minus 6 is negative 2. 4 minus negative 2 gives you positive 6 divided by 2 gives you 3. So given 2 points, find their slope. That's the bottom line. Part B, find the instantaneous rate of change of f of x at x equals 4. What I want to quickly explain before we move on. Even if they don't mention average and they say just find the rate of change, when they are given you 2 points, that means average rate of change. Even if they don't say instantaneous, find the rate of change of f of x at x equals 4. When it's 1 point, means instantaneous rate, means differentiation. Please understand, later on, we're going to go with the easy way out with formulas, but for now, we have to go with the definition. And there are 2 definitions. I'm going to start with one of them. And in fact, I'm going to continue with the second one just for practice. So if we use this one, which is normally used, the limit of f of a plus h minus f of a over h as h approaches 0, and replace the a with 4. So what do we do? So basically, you can develop this, simplify, and then apply the limit. This is one way to do it. Or just keep on with the limit sign. It's your choice. But at the end, you have to apply the limit. So if you want to just evaluate this expression and simplify it, that's fine. So what is f of 4 plus h? 4 plus h squared minus 3 times 4 plus h. Minus, what is f of 4? You don't have to, I mean, you can plug in 4 squared minus 3 times 4, or just remember f of 4 was evaluated at 4 already. You could do that. So let's write them. This one, I'm going to use the 4 that we had. Okay, we had the 4. So I'm not going to evaluate it again. This one, I want to remind you, 4 plus h squared. When you calculate a plus b squared, you get a squared plus 2ab plus b squared. Please do not miss the middle term. So this is 4 squared, 16, plus 2ab plus 2 times 4 times h, plus 8h plus h squared. This is simple. Minus 12 minus 3h minus 4. So the numbers 16 and negative 12 and negative 4, they cancel each other, they give us 0. 8h minus 3h, they add up to 5h. We also have the h squared. We're going to factor out the h. The h drops out. And now you are going to plug in. It is extremely important for everybody to remember, if you want to just write this expression, this expression, this expression, this expression, and this expression, and simplify it is fine. But at the end, if you wrote 5 plus h equals 5, that is wrong. You must write the limit of a 5 plus h as h approaches 0 is 5, because those are two different things. This one, 5 plus h is 5 plus h. This one, when h approaches 0, if you replace it, then you get 5. Now we are done with this. However, I like to use this one also for practice, which means I want f prime of 4, the limit of f of x minus f of 4 over x minus 4 as x approaches 4. So f of x is x squared minus 3x minus f of 4. Again, I'm going to use the fact that we found it to be 4. I want to factor it. I want two numbers. The product is negative 4. The sum is negative 3. Also, because x approaches 4 and the denominator is x minus 4, I hope you recognize this is 0 over 0, which is indeterminate form. And it is the 0 in the denominator. This is the one that creates a problem. So you're hoping to get rid of it. How? Factoring. So you're hoping this has a factor of x minus 4, and it does. And I'm telling you this because it should help you find the factored format easily. And as you can see, now you plug in 4, you get the same answer as you should. Do we have to do both ways? Absolutely not. I'm doing it just to make a point. Both of them are just as good, just as easy.
Doctor, did you see my Dr. A, did you see my question in the chat?
It's hard to hear you. I'm sorry. What is your question? Let me finish the recording and I get back to you, and we will go over that question for you. Okay. So please, because it's very hard to hear you, and please let me finish that. All right. We want to find an equation of a tangent line to the parabola y equals x squared at the point P having coordinates 1, 1. So in order to find the equation of any line, you need two things. You need a pair x comma y, it's given. You also need the slope. And the slope can be found using one of these formulas. So in this case, of course, a is 1, the x coordinate. And the function, of course, y or f of x equals x squared. So we're going to use one of them, let's say the top one. I'm going to use that one to find m or f prime of a. Therefore, m or f prime of 1 equals the limit of f of x minus f of 1 over x minus 1 as x approaches 1. We're going to replace f of x with x squared. F of 1, you can plug it in, but I mean, in general, when the y coordinate is given, I hope you realize f of 1 meaning the y coordinate of the pair, since the pair is given. Although they don't have to give you the pair, they can just tell you at x equals 1, and then you can figure out the pair. So minus f of 1 over x minus 1, f of x is replaced by x squared. And this is in the form of a squared minus b squared. You factor it into a minus b, a plus b. One is 1 to any power you want it to be, 1 squared, 1 cubed, you name it. And therefore you have x minus 1x plus 1 for the numerator. These two cancel each other. We get limit of x plus 1 as x approaches 1. And now if we plug in, we get the slope equals to. Now we're going to use the point slope. Y minus y1 equals m times x minus x of 1, meaning y minus 1 equals m 2x minus x of 1, meaning x minus 1. And we're going to simplify this. We get 2x minus 1. So y equals 2x minus 1. If you want to check your work, when you plug in this pair, it works, means these steps, all of these steps are correct. Doesn't say anything about this slope. And you're done with that. What I want to add, class, I want to show you the second method of finding that for the sake of practice only, for the sake of practice only, everybody. Okay, so we are going to go this route where a is 1 and the function is x squared. So m is the limit of f of a plus h. You replace the a with 1 minus f of 1 over h as h approaches you. Now we are going to find f of 1 plus h. That means into x squared goes 1 plus h. As far as f of 1 is concerned, the y coordinate is given, class. Okay, so you don't have to evaluate. Again, 1 plus h squared. I've discussed a plus b quantity squared. So square this one, you get 1 plus 2 times the first times the last 2h plus h squared. 1 cancels out the negative 1. These two we can take a common factor of h out. These two cancel each other. And now you have the limit of 2 plus h as h approaches 0. If you replace it, you get 2 as we had it before. And the idea here is Very straightforward, everybody. Both methods should result in the same answer. They do. You don't have to do both methods, but for practice, it is helpful to do so. All right, we want to find the derivative or instantaneous rate of change of f of x of this function f of x equals x squared minus 8x plus 9 at this number x equals 5. So whether we say find the derivative or instantaneous rate of change at a specific point means the same thing, or the slope of a tangent line at x equals 5, they all mean the same thing. So what do? We put it in one of these definitions. For example, if we go with this one, if the limit of f of a plus h minus f of a over h as h approaches 0, where a is 5. So we're going to put 5 plus h squared minus 8 times 5 plus h plus 9. Then minus f of a, plug in a or 5. Okay. 5 squared minus 8 times 5 plus 9. Rather than evaluating this in one shot and applying the negative, I want to do the following. So take a look. This becomes 25. Then 2 times 5 times h is 10h plus h squared. This becomes minus 40. This becomes minus 8h. This becomes plus 9. The rest of this is 25. This is 40. This is plus 9. I'm going to apply the negative sign and change the sign. Why am I doing this? Because I want you to notice these two cancel each other. These two cancel each other. These two cancel each other. So we end up with h squared and 2h. That's all in the numerator. So I hope you see there's a lot of algebra involved. In the numerator, I can take the h out. 2 plus h. These two cancel each other. Replace the h with 0, and here's your final answer, 2. Okay, everybody? That's the final answer.